Welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm your host, Avery.
And I'm your co-host, Anna. It's great to be with you all again. Avery, here in the Northern Hemisphere, it feels like the nights are really drawing in, getting colder, darker.
They certainly are. But that darkness isn't always a bad thing, especially when it becomes a canvas for some of the universe's most incredible art. And we're starting today's show with just that.
That's right. We have a packed episode, from spectacular atmospheric light shows right here at home to the ultimate fate of Earth itself.
And we'll also look at potential threats from outside our solar system, find a beacon of hope on an icy moon, and preview an exciting new mission to Mars. So let's get right to it.
I'm ready if you are.
Alrighty. Our first story is a visual feast. For anyone lucky enough to be in the right place at the right time between November 5th and 8th, 2025, the night sky put on a show for the ages. A powerful geomagnetic storm triggered stunning auroras.
It really was something special. This was classified as a G3 class storm on the 5-point scale, which is considered strong. It was all thanks to a significant coronal mass ejection, or CME, that erupted from the sun a few days prior.
Right, a CME. So basically the sun threw a massive blob of plasma and magnetic field our way?
Exactly. When that wave of charged particles hits our magnetosphere, it channels them towards the poles. They rain down into our upper atmosphere, collide with air molecules, and energize them, causing them to glow. The beautiful greens are from oxygen, while rarer pinks and reds come from nitrogen.
And this storm was powerful enough that the lights were seen much farther south than usual. We saw incredible photos and time lapses from the northern United States, the UK, and all across Scandinavia. It must have been just breathtaking to see in person.
It truly is an experience that connects you to the cosmos. It's a vivid, dynamic reminder that we live inside the atmosphere of a star, and that our sun is an active, powerful force. We're currently in an active period of the solar cycle, so we might get a few more shows like this in the coming years.
I certainly hope so. A beautiful event and a great way to start our cosmic journey today.
From the beautiful effects of our star's activity to a more sobering look at its eventual demise, our next story comes from NASA's Transiting Exoplanet Survey Satellite, or TESS. And it paints a stark picture of the fate of planets orbiting sun-like stars.
TESS. Its main job is hunting for exoplanets, but it's great at just watching stars. What did it see this time?
It was watching older stars, those beginning to enter their red giant phase. And the new study confirms that these swelling stars are engulfing their inner planets far more often than some models predicted. The evidence is in the starlight itself. They can detect the chemical signatures of planetary material being consumed by the star.
Consumed. That's a gentle word for it. It's more like being vaporized and eaten.
A very accurate description. As a star like our sun exhausts hydrogen fuel in its core, it starts burning it in a shell, which causes its outer layers to expand enormously. It can swell to hundreds of times its original size.
And any planets in the way?
Any planets in the way are first subjected to immense tidal forces that can tear them apart, and then they are swallowed by the star's expanding atmosphere, the photosphere.
Which brings us to the big, scary question. What does this mean for Mercury, Venus, and us here on Earth?
Well, Mercury and Venus are almost certainly doomed. As for Earth, the picture is now looking grimmer. While some models suggested Earth's orbit might widen and save us, this new data suggests the sun's expansion will be too aggressive to overcome that shift.
It does. But let's not forget, this is about 5 billion years in the future, so there's no need to sell your stocks just yet.
Exactly, but it's a profound look into the celestial mechanics that govern the birth and death of worlds. It gives us a real sense of cosmic perspective. Our planet has an expiration date written in the stars.
Okay, from a threat 5 billion years away to one that is, well, less predictable. A fascinating new piece of research is helping us understand the risk of impacts from interstellar objects, or ISOs.
These are the cosmic nomads, objects like asteroids and comets that have been ejected from their own star systems and are now wandering the Milky Way.
That's them. We've had 3 famous visitors so far that we know of. The strange cigar-shaped Oumuamua in 2017 and the more comet-like Borisov in 2019. Then there's the current one everyone's talking about, 3I-Atlas. Those 3 flybys prove that these objects are out there.
Right. And now we want to know how many more there are and what the chances are that one might hit us.
Precisely. This new study tells us where we're most likely to see them coming from. The solar apex. That's the direction our solar system is traveling as we orbit the galaxy. It's what's in front of our cosmic windshield, so to speak.
So we're essentially running into a stream of these objects as we travel through the galaxy?
It does. The study also pointed to the galactic plane as another likely source. Now, to be clear, the researchers stress that the probability of an impact from a large ISO remains extremely low. There's just a lot of empty space out there. But for planetary defense experts, this is crucial information. It tells them where to prioritize their search efforts. It's about being smart and looking in the right direction for these very faint, very fast-moving objects.
So it's another step towards creating a comprehensive map of potential hazards, both from within and without our solar system. Fascinating stuff.
All right, let's leave the threats behind and travel to Saturn's icy moon Enceladus. It's getting more promising in the search for extraterrestrial life, thanks to a fresh look at old data from the Cassini mission.
It absolutely is. Cassini orbited Saturn from 2004 to 2017, and scientists are still making incredible discoveries from its data archives. The big news we've known for years is the South Pole, with its Demise tiger-striped fissures that blast plumes of water from a subsurface ocean into space.
Yeah, an underground ocean of liquid water. That alone is amazing.
It is, but the North Pole was always considered the boring one, frozen, ancient, and inactive. Well, by reanalyzing thermal data from Cassini's flybys, scientists have now discovered a significant heat signature coming from the North Pole as well. The ice is much thicker there, so it was trapping the heat, but it's definitely there.
Wow, so the moon's internal engine is heating it at both poles. What does that imply for the ocean?
It implies the ocean is truly global and that the geological activity isn't just a recent or temporary phenomenon at one pole. A sustained global heat source means this ocean has likely been stable and warm for billions of years.
And that is the magic ingredient. A stable environment. It gives life, if it were to start, a real chance to take hold and evolve.
Precisely. We're talking about a world with liquid water, organic molecules, which Cassini also found, and now a long-lasting source of energy. That's a perfect trifecta for habitability. It makes Enceladus arguably the most compelling target for future astrobiology missions.
We just have to go back. We have to sample those plumes and see what's really in that water. And while a mission to Enceladus is still on the drawing board, our final story is about a mission that is very much on the launch pad. On November 9th, 2025, which is this Sunday, Blue Origin is set to launch its first ever interplanetary mission using its heavy-lift New Glenn rocket.
This is a big step for the commercial space industry, and it's a NASA-funded mission they're carrying, right? A great example of public-private partnership.
It is. The payload is a mission called Escapade, which consists of 2 identical probes destined for Mars.
Escapade. I like the name. What's their purpose?
They are designed to solve one of Mars's biggest mysteries, how it lost its atmosphere. We know Mars was once warmer and wetter with a thicker atmosphere, but over billions of years, it was stripped away by the solar wind.
Right, and that happened because Mars lost its global magnetic field, which acts as a protective shield for a planet's atmosphere. Earth's magnetic field protects us from the same fate.
Exactly. Mars now only has these localized remnant pockets of magnetism in its crust. The 2 Escapade spacecraft will orbit in formation, allowing one to measure the incoming solar wind while the other measures the atmospheric effects at that exact moment.
This will give us the first ever 3D picture of how the solar wind is siphoning off what's left of the Martian air. It's fundamental science for understanding how a habitable planet can become an inhospitable one. A cautionary tale, perhaps.
A very important one. It's a fantastic mission and a huge milestone for Blue Origin. We'll be watching that launch closely.
And with that, we're out of time for today's episode. What a journey across the cosmos.
The universe never fails to deliver. A huge thank you to all of you for listening to Astronomy Daily. Join us next time for another journey through the cosmos. Until then, stay curious and keep looking up.